Hello, it's Dave Giles again, and welcome to the third lesson on Cambridge International IGCSE Thermal Physics. Today, we are looking at Brownian motion. So our learning objective for this lesson is to describe the particle movement in Brownian motion. So this here will be a new topic to you, which you didn't cover at Key Stage 3. So first of all, particles move in straight lines. They also move, like in this diagram here. So how can both be true? So it looks like they're traveling in zigzags, but they also only travel in straight lines. So what is causing this? Well, we can use a little analogy. So this here is a game of football. You can see the ball starting here. It's headed to kick to this person who heads it over here, who passes it here, who runs around some players, and then it's kicked into the goal by the number 9 striker here. Now, imagine we took away the football players and just looked at the motion of the ball. So it started off here, moves there, moves there, moves there, moves there, there, etc., etc. That is what the movement of the ball alone, without the football players, would look like. And it's similar to Brownian motion. Because Brownian motion is the random movement of particles in a fluid. And what happens is the smaller particles, the big particles, are bombarded and being constantly hit by other smaller moving particles in the fluid. So you can think of the footballers, even though it's a little bit of a different analogy because the football is actually bigger than the football. You can think of the footballers as being the little small particles which keep on hitting the ball. And it's also evidence for kinematic molecular model of matter. So if we look here at pollen grains in water, you can see they appear to be moving a little bit randomly. However, if we were to just look at one particle here on its own, you can see the large green particle is moving about in a zigzag direction. And you can see it's because other particles are hitting it or bombarding it, and that is causing it to constantly change direction. However, if I remove the small particles from this drawing or from this animation, it would look like the green ball is just moving completely at random, which you can see it isn't. And if you look at one example, a typical one we'll ask you about in an exam, is looking at smoke particles under a microscope. Now, the smoke particles themselves kind of glow, sort of a bright orangey yellow color. And if you look closely, you can see those small particles moving around in what appears to be a bit of a random direction, but it's because it's constantly being hit by other smaller air particles. Okay, so now we'll take a look at some past paper 2 multiple choice exam questions. So first one, which diagram best shows the path of a gas molecule? Okay, it's most likely going to be D. Okay, next question. Small smoke particles suspended in air are viewed through a microscope. The smoke particles move randomly. What does this show? Give you a few seconds to think about it. Pause it if you need to. It shows the air is consistent of fast-moving molecules, which is what's causing them to change direction and move randomly. Okay, question 3. Viewed through a microscope, very small particles can be seen moving with Brownian motion. Which line in the table is incorrect? So which one is wrong? Sorry, I misread that, sorry. Which line in the table is correct? My mistake. Well, the type of motion is random. And in order for it to happen, it needs to be in something where the particles can flow. So they can flow in a liquid and gas, so a fluid, but particles don't flow in a solid. So the answer is C. Okay, so now I've got some mixed paper 2 and paper 4 questions. what I'd like you to do is pause it for a minute, have a go at these questions. So I'll pause it, let you have a go, and then we'll go through it in a moment. Okay, first question from this list. Brownian motion is seen by looking at smoke particles through a microscope. How do the smoke particles move in Brownian motion? At random. Why do the smoke particles move randomly is the next question. It's because they are hit by air molecules. The third of the paper 2 questions here. Extremely small pollen grains in water are viewed through a microscope. The grains are seen to move continually and randomly. What is the reason for this random movement? It's because the grains are moved randomly by randomly moving water molecules. Okay. And then there was a paper 4 question. The first part here. Describe what is seen when the smoke is viewed through a microscope. Bright specks or dots or flashes of light moving randomly or in a zigzag pattern. In the space below, sketch how one smoke particle might move during a short interval of time. So the 2 marks for a line representing a smoke particle moving with a change of direction. Line is straight, but with at least 2 changes. So basically, it should be very similar to this diagram here from question 2. What caused the smoke particles to move? It's collisions or bombardment with air, atoms, molecules, or particles. And the last question is the easiest of them all. What name is used for this motion of the smoke particles? Complete the sentence. The motion of the smoke particles is known as Brownian motion. Okay, so that is the end of the lesson describing the particle movement in Brownian motion. The next lesson, which I will upload later, and I will post a link to it down below, is on thermal expansion. Okay, thank you very much, everyone. I'll see you in the next lesson.